Good evening, my YouTube viewers. In this video, we're going to be talking about seasonal decomposition and ARIMA, and we're going to write a program in Python to demonstrate that. So in order to write the program in Python to demonstrate that, the first thing that we're going to do is we're going to import some libraries, because you need the libraries to actually execute the program. So we're going to import NumPy as NP, which is the numeric library that also creates the NumPy arrays. We're going to import Pandas as PD, which is the data processing library, which also creates data frames and series. We're going to import matplotlib.pyplot as PLT, which is the visualization library. And from statsmodels.tsa.seasonal, we're going to import seasonal decompose. So statsmodels is Python's statistical library. TSA is the time series analysis module within that library. And seasonal is a module within TSA. And seasonal decompose is a function that we're going to be using to decompose the signal. And then from statsmodels.tsa.ARIMA model, import ARIMA. So ARIMA is a function that we're going to be using to actually forecast the data. So after we have imported our libraries, what we're going to do is we're going to generate some synthetic data. So first thing that we want to do is we want to set our seed. And so we'll set the seed by typing np.random.seed, and you can type any number that you want within the brackets. And basically what that does is every time you run the program, it will initialize to the same values. So we set up days equals pd.daterange brackets start equals 2023-0101, comma, period equals 365, comma, frequency equals D, so 1 year of daily data. Marketing spend equals 50 plus 5 times np.sign brackets 2 times np.pi times days.day of year divided by 365. So that's your seasonal marketing trend. Noise equals np.random.normal. Normal is a normal distribution, bracket 0, 10, len days. And that's, you're putting some noise in the sales figures. Baseline sales equals 200 plus 2 times marketing spend. So that's the base sales depending on the marketing. And total sales equals baseline sales plus noise. And so that's the total sales with random fluctuations. So we're going to create a data frame for the data. So data equals pd.dataframe, brackets, curly brackets, date, colon, days, comma, marketing spend, colon, marketing spend, colon, comma, sales, colon, total sales. And then so basically what that does is dates is your first column of data, marketing spend is your second column of data, and sales is your third column of data. And then we're going to data.setIndex, brackets, date, comma, in place equals true. And then so we're going to set the index to the date. So your date is going to be the index, and marketing spend will become the first column of data, and sales will become the second column of data. So now we're going to do the seasonal decompose to analyze trends and seasonality in sales. The period parameter is changed to 365 to reflect the annual seasonality. So decomposition equals seasonal decompose, brackets data, square bracket sales, comma, model equals additive, and then period equals 365. Decomposition.plot, plt.subtitle, brackets, seasonal decomposition of sales comma, font size equals 16, PLT equals show. And now we define our model. So we're going to use ARIMA to model and forecast sales. Train data equals data, square bracket sales, square brackets colon to 300. And so we're going to use the first 300 days for training. Test data equals data, square bracket sales, square brackets 300 to colon. And we're going to use the last 65 days for testing. So now we set our model. Model equals ARIMA, brackets train data, comma, order equals 212. So that's the ARIMA model order as PDQ as 212. And model fit equals model.fit. So one thing that you would need to do is you would need to calculate your PDQ. And in the last video that I did, after I completed the video, I calculated the PDQ and I said what the PDQ should be to get like an optimum forecast. And so I looked at the graph that this made, and I think an optimum forecast is not going to be 212. So it depends on how I feel as to whether I'm going to calculate the PDQ again. But if I do calculate it, I'll put it in the description box of the video so you can see it. So we forecast the sales for the test period, and forecast equals model fit dot forecast brackets steps equals lin test data, forecast index equals test data dot index. So now we plot the observed versus the forecast sales. PLT dot figure brackets fig size equals 6,4, PLT dot plot brackets data dot index, comma, data square bracket sales, comma, label equals observed sales, comma, color equals blue, comma, alpha equals 0.6. PLT dot plot brackets forecast index, comma, forecast, comma, label equals forecast sales, comma, color equals orange, comma, line style equals dash. And then now we're going to put a vertical line in the chart. So PLT.AXV line brackets X equals train data dot index square brackets -1, comma, color equals gray, comma, line style equals dash, comma, label equals train test split. Okay, and then now we're going to add labels, title, and a legend to the graph. The title is Sales Trends and Forecasting using ARIMA. The date is X label, Y label is sales in dollars. You get a legend, you get a grid, and then they're going to show it. So this is your seasonal decompose part of the graph. So you get your seasonal decomposition of sales, you get your sales, you get your trend, you get your seasonal, and then you get your residuals. And then you got your sales trends and forecasting using ARIMA. So blue is your observed sales, orange is your forecasted sales, and green is your train test split. So after I finish this video, what I might do is I might calculate the PDQ and then give you the code for the PDQ in the description box of the video so you can see that the PDQ, the forecast, will be better if you get the correct PDQ range. So that concludes this video, and the next video is going to be on a time series topic. So I hope you decide to watch it.